Hello, let's solve a problem on the flux passing through a cylinder. So the question is, consider a cylinder of height h and radius a, right? Closed at both ends, centered at the origin, right? Then let x I cap, y j cap, z k cap be the position vector and n cap unit vector normal to surface. Then the surface integral r bar dot n cap ds over the closed surface of cylinder. Right? Here it's a given the cylinder, so let's start the solution. Here it is given that there is a cylinder of height h. This is of height h, right? And radius a. This is radius. This is centered at the origin. Let's take this as x, y, and z, right? Then we need to figure out the surface integral r bar dot n cap ds over the closed surface of a cylinder. So let's start. We can do this in two methods. We can directly proceed with the given integral r bar dot n cap ds, and we can convert it into Gauss divergence theorem, and we can do it very easily. So let's try it in both methods. So let's try using the Gauss divergence method, right? In Gauss divergence method, right, it will be very easier. In Gauss divergence theorem, right, which states that surface r bar dot n cap ds is del bar dot r bar dv. Fine. So let's proceed. Here given r bar as x, y, z, that is xi, yj, and zk, right? Then we need to figure out this value. So we can convert this using the Gauss divergence theorem into a trivial integral, and we'll integrate over the entire volume. So to figure out this integral, let's calculate this value, which is a scalar, right? Which is del bar dot r bar, which is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap dot xi cap plus yj cap plus zk cap, which is dou by dou x of x is 1, right? 1. Similarly for y and j, which is 3. So this is double integral, yes, r bar dot n cap, sorry, ds is triple integral del bar dot r bar is 3, which we can write it out of the integral, into dv. This is the volume of the cylinder, which is 3 times of pi a square h. So this is, you can just write this surface integral as r bar dot n cap ds is 3 pi a square h, right? This is the solution, right? You can just go directly without proceeding, without using the Gauss divergence theorem, but it will be more complicated. Let's make a try and see whether it's true, right? In the curved surface, first we need to calculate using direct method. That means we are not using any Gauss divergence theorem here, just evaluating. So in the Gauss divergence method, we have just applied del bar dot r bar and proceeded. Here, let's first calculate the curved surface, okay? Curved surface of a cylinder. Here, as you can see, z varies from minus h by 2 to minus h by 2 to h by 2, right? Z varies from minus h by 2 to h by 2 because its origin is centered. So for this case, we need to calculate, yes, r bar dot n cap into ds, right? For the curved surface, right, what is n cap? I mean the vector which is normal to the curved surface, which will be of this form. Here, to calculate this, let's evaluate. Here, n cap will be cos theta I cap plus sin theta j cap, right? This will be the normal, and there will be no k component because it's k component. If you add k component, it will be perpendicular. I mean, it will be along the z direction, right? I mean, as you can see, for this curved surface, a vector must be perpendicular to k cap, right? So n cap equal to cos theta I cap plus sin theta j cap. And here, what about the r cap, which is x, y, z, and x is cos theta, right? Cos theta, which is a cos theta because of radius a cos theta I cap plus a sin theta j cap and z k cap. Fine. Now let's evaluate this r bar dot n cap, which is a cos square theta plus a sin square theta, and z into 0 will be 0. So this will be a into cos square theta plus sin square theta, which is a, and a into 1 is a. So now this is, I mean, instead of writing double times, just write a surface integral here. It's more than enough. R bar dot n cap ds is, r bar dot n cap is a, which we can keep it out, and we need to calculate the surface integral ds. Right? What about the curved area? This area, if you are calculating the whole curved area, which will be written as a into double integral, right, a dz into d theta. I mean, you can just write it simply here. Let's calculate from the top view. This will be of this form, right? If you are calculating the area, curved area of the cylinder, you need to calculate the area of this circle and to multiply with height, right? So this will be, this length will be, if this is a, then this will be a d pi, right? To calculate the whole area, you need to integrate, let's this as a small surface area, then this will be dr, this area, I mean this length, into this small length will be along the perpendicular to radial, this will be r d pi, sorry, r d theta. Then this small integral, the small patch area is r dr d pi. If you integrate if you integrate r from 0 to a and phi from 0 to 2 pi, then you will cover the entire area. So here theta is from 0 to 2 pi, and what about the height? H, it's from minus h by 2 to h by 2, right? This a will come out, which is a square, and to integral d theta you can simply write it as 2 theta, because integral d theta is t theta, and theta, if you substitute 2 pi minus 0, it's 2 pi. Then it's dz, integral dz is z, which is h by 2 minus of minus h by 2 plus h by 2, which is 2 pi a square into h, right? This is the curved surface part. Now let's figure out the contribution from the top surface, right? Top cap of cylinder. At this top cap, as you can see here, it's centered, then this top cap is h by 2, then this down part is minus h by 2, right? Here in the top cap, z is plus h by 2, right? Then outward normal, here it is along the positive z direction, which is k cap. Fine. Then r bar dot n cap is, because it's only k cap, the z component of this r cap contributes, then this will be, what is this? This will be z, which is h by 2, right? So this will be, let's calculate this integral r bar dot n cap ds is, r bar dot n cap is h by 2, right? Then you need to calculate the area of this top part of the cylinder, which is r a will be 0 to a. Similarly, here it's the same, right? What you have done here, it is 0 to 2 pi theta part h by 2 into r dr d theta, which is h by 2 into d theta. If you integrate first, then it will be 2 pi. This is r dr, which is r square by 2, then it will be a square by 2 finally, right? This 2 will get cancelled, then this will be pi a square h by 2. Then let's calculate bottom cap of cylinder, its contribution. Here, as you can see, here it's z equal to minus h by 2, and here the unit vector perpendicular to this bottom cap is minus k cap, right? And here r bar is, here r bar dot n cap, right? Even here in the r bar case, here it will be z component will be negative, right? Because we are doing it in the because we are here, this will be, z part will be negative. So here r cap dot n cap, because n cap is k cap, the only z component of it will contribute, because this position vector will be now in the downward direction, which is negative of the z axis. Then this will be minus, right? Minus z, right? Because n cap is cap. Here z is minus h by 2, which is h by 2, right? I mean, you can see this xi cap plus yj cap plus zk cap into k cap, right? These two terms will not contribute. So z into k cap dot k cap is z, because this z is in the downward direction, I mean negative axis of negative axis of z, so this will be minus h by 2, minus of minus h by 2, which is h by 2. So let's calculate this part for this case. R bar dot n cap ds is it's will be the similar. I mean, you can just see h by 2 here. You just need to integrate and you will get the same value here, which is pi a square h by 2. So finally, I mean, you can just write this case. This is bottom, this is top, this is curved surface, right? Then the total R bar dot n cap ds is 2 pi a square h plus pi a square h by 2 plus pi a square h by 2 is 3 pi a square h, right? So finally, you can do it in two methods, but using Gauss divergence theorem is a little bit more simpler. This will be 3 pi a square h. This is the final answer.